If you have the textbook, it's on page 20. Alright, question 3, it says that 2 shells are being fired from a battleship at 2 enemy brigades. They gave a diagram, okay, that shows something like that. Okay, so there are 2 enemy brigades in this position. Okay, so in the very first one, I'm not sure which one is it. Okay, it is being modeled by this equation here. Okay, part I, it asks how far is the enemy brigade from the battleship. So let's assume that this equation is representing this first path. Okay, is this taller path here. Right? To know how far the enemy brigade is from the battleship, let's try to interpret this question. When you're in this position, with this being the x-axis and this being the y-axis, what's the coordinates of this point? What's the coordinates of this point? 0. We are trying to see that y is equals to 0, right? And if I can find out what is the x, that will actually be the distance from the battleship already. So to solve part I, we are trying to substitute in when y is equals to 0. Okay, and then after you solve for the value of x. How many x values will you expect? 2, right? Okay, so one of which will actually be 0. Why is that so? Because this path starts from the battleship. The one where x equals to 0 is where the battleship is. Okay, the other one will actually be the answer to your question in part I. Right, so I'll leave it to you to solve it on your own. Part 2, what is the maximum vertical height? Maximum vertical height, it will mean that it is the turning point. In fact, it is the y coordinate of the turning point. So can we find the x coordinate of the turning point? We can, right? Because I know the x-intercepts already from my answer in part I. The turning point is right in the middle of the two x-intercepts. So you can find out what is the x coordinate of the turning point. Okay, for which you will get something here. Just use a triangle. Okay, and then to find out the y coordinate, you substitute it back into the original equation of that motion. Okay, that's how you solve part 2. Then in part 3, the vertical height of the second shell. So we're looking at a different motion now. So looking at, assuming the lower one is now the second one. Okay, it is being modeled by a different equation. Okay, this one over here. It says that if the second enemy brigade is 3 kilometers, okay, from the battleship, justify whether the second shell will hit it or not. Okay, so we're looking at a distance of 3 kilometers. But based on the definition of the variables in the question, your x and y, they are defined to be in meters. Okay, so you need to convert the 3 kilometers into meters first, which should be 3,000 meters now. Okay, so when x is equals to 3,000, you can find out the value of y. Okay, to know whether it will hit this enemy brigade or not. Okay, if your y is equals to 0, that means that it lands here, right? That means that it will hit the enemy brigade. If it is anything that is more than 0 or less than 0, that will mean that it totally misses, okay, the enemy brigade or not yet even reach the enemy brigade. Understand? Okay, so therefore, what we have to do is check whether y is equals to 0 or not. Okay, so if y is equals to 0, then yes, it hits. Okay, if y not equals to 0, then your conclusion will be no. Right, I'll leave it to you to phrase it in your own words. Okay, otherwise you'll just be me doing your homework. Yeah. Because when you are looking at the x-axis here. At this point, what's your coordinates like? Y is equals to 0, x equals to something. So x is actually 3000 because that is the position of the enemy brigade. So we want to check whether this path, okay, your y is equals to 0 or not. That's it. Alright, next we look at question 5. Okay, question 5, it says that a section is of a curved cable of a suspension bridge can be modeled by a quadratic function. So they show you some suspension bridge with a section of a curved cable or with a curved cable. Okay. Horizontal distance and y meters is the height of the cable itself. Okay? Vertical supporting wires are spread out in equal intervals of 1 meter apart, hanging from the cable. The longest length, so all these things here, 40 meters and 10 meters, they are just supporting wires, okay, to hold the cable up, okay, so that it is suspended. So the longest length is 40 meters and then the shortest one is 10 meters. Okay, you can ignore about the 1 meter spacing one because they just didn't illustrate it. Right? It will be too many to illustrate. Okay, the two longest wires are actually 200 meters apart. In part I, we want to find a quadratic function in a certain model, in a certain format. Okay, and this format is a format that will facilitate our identification of turning point because our turning point will be HK. Okay? Are we able to tell what is the turning point based on the diagram alone? Okay, our turning point is a minimum point which is here, right? Okay, so what is the x coordinate and what's the y coordinate?
X is 1.
X is 1. 100, okay? Yes, x is 100 right in the center, right? And then y will be 10 meters. Okay? So we are able to see that regarding the x coordinate, h will be 100, so we've got minus sign. Okay, and then k will have to be 10. Okay? Then the remaining thing for us to determine is the value of a. Right? How can we find the value of a? The other information we have yet to use is this 40 meters. Okay? Few ways for you to use the 40 meters. At this particular place, this point here has a coordinate x to be 0, y to be 40. Okay? Likewise over here, it is actually x coordinate is 200, y coordinate is 40. So you use either one of this set of coordinates and substitute inside here, and you will be able to find the value of a already. Okay? Doesn't matter which one you use. Right? You can use this one or use this one. But you need to be able to interpret this out of the diagram. Okay? Questions? Yes. X to be 100, x to be 0, y to be 40, then you can find a already. That's all. Okay? Anyone else? Yourself can please wake up. Okay. Next, part 2. Find the length of the vertical supporting wire that is 30 meters from the origin. So, because this diagram only shows us 3 pieces of supporting wires, this piece here, this piece and this piece. They now say that there is another piece that is 30 meters horizontally from the origin. Origin is here, 30 meters, maybe somewhere here. Okay? So they want you to find out what is this length. And that is when you substitute in x to be equal to 30 into your newfound equation, then you will be able to determine the y. Alright? how we solve part 2. Okay, next, we look at question 8. Would part I be a problem? Part I is a problem. What do you understand about part I? Expressed into this form, what does it mean? What does this form here actually mean? Can someone help? What does this form want us to do? Factorize. Okay, so this is a factorized form, so all we have to do with this part I is that with the given equation, we just have to factorize out 4t, we'll be left with 2 minus t. Okay, so how does this compare? It is actually a very specific form. If you want to be matching this one, which is not necessary, okay, it is of this form. Your t means t minus 0. Okay, 2 minus t, right, you can flip it around. You want to write it as negative 4. T minus 0, t minus 2, that's fine as well. Okay, but essentially what you interpret from this idea is that they want you to factorize. And this is good enough already. You need not give me this. Because t minus 0 in fact is not simplified. You should give me 4t. Okay? So I wouldn't be expecting either one of this. Because this one is not simplified. Okay? So this form is just a very generic form to tell you that you need to factorize. It doesn't mean that you must exactly follow, okay, the form in a match or in a corresponding manner. Okay? Then in part 2, find the intercepts and the coordinates of the turning point of h against t. Are we able to find intercepts? I think we should, right? How do we find the intercepts? How do we find the intercepts? When y equals to 0, that will help us to find the x-intercept. In fact, there's no y over here, it's h and t. So when h equals to 0, and then when t equals to 0, it will help you to find the h-intercept. Then to find the turning point, okay, you can use the 2 t-intercepts, find the t coordinate, and then after that substitute back in to find the h coordinate. I will not repeat part 2. You're expected to do that. Part 3, to find the maximum height, you just reference to the turning point. Okay, so part 3 should not actually be a problem as well. Part 4, find the time taken it takes the ball to return to the ground. So to return to the ground, what does that mean? I cannot be the only one thinking over here. How so many people do homework? What does it mean when the ball returns to the ground? H equals to 0. Okay, so you start in when h equals to 0, which actually you did it here already. Right?
Yes.
Okay, part 5. A player whose height is 1.8 meters wishes to hit the ball as it is falling. Find the earliest time he can do so with his feet on the ground. Okay, so what you want is 1.8 meters. graph that will represent like this. The motion of the ball is like this. You have 1.8 meters ball. Okay, so let's say this is where 1.8 meters is. Okay, we want to determine the earliest time. There will be two time sections, junctures. Okay, try to find a word for it. Alright, so you have your T and your H here. There are two time junctures whereby it will be 1.8 meters. Because we want to find the earliest time, we will take this as the answer. But of course, we are not trying to draw a graph over here. We are trying to substitute in H to be equals to 1.8 and then solve the equation to see what are the two time values. Okay, to see what are the two time values and then you take the earliest one because the question asks for the earliest time. Okay? Any questions? Yeah. Yeah, the ball is falling what? This motion is the ball falling, right? Oh, you mean as it is falling. Huh? Yes. For part I, how to get the turning point? You have the t-intercept, right? There's the x-intercept. Then after that, divide by 2. Then you will get the x-coordinate of the turning point. Then after the y-coordinate is up inside here. That value of t. Okay? When the ball is falling, what's the answer actually? Is that the second answer instead? Oh, okay, yes. Okay, sorry, I missed out that part of the question. It says that the ball is falling, okay, which I think Vicky also very rightfully pointed out. Over here, the ball is rising, right? It isn't quite falling. Okay, so actually it shouldn't be this answer here. It should be this answer. Okay?